Hi, this is Aaron Lewis from Franklin Maths. This lesson is on the hypothesis testing with the normal distribution. This is the first year hypothesis testing. In the second year, we'll look at hypothesis testing with the normal distribution. Okay, so I've got a scenario for you. We've got a coin that we suspect of being biased, and let's just think about what evidence would we need to support this claim. So I've got a coin. I think, hang on, this will land on heads. Have a think. Just pause the video and have a little think. So what I thought of was, how many times will the coin be thrown? How many times do you have to throw it before we decide it's going to be biased or not? It's 10 times, 100 times, million times, infinite amount of times to just keep throwing it and keep tallying it. And clearly that's not a great idea, but certainly that needs considering. How many times will it be thrown? And also, how many times will it need to land on heads for us to determine whether it's biased or not? So if we're going to throw it 10 times, what does it need to land on it 9 times? Maybe just 6. Well, it's more than half. 100 times 60. But this is what we're going to look at today. How we can actually, we're not going to be proving it. We're just going to be providing evidence to suggest that the coin is biased or not. Okay, so this is what we're going to look at with the hypothesis testing with the binomial. Okay. So first thing we're going to do is we're going to look at what is known as the null and alternate hypothesis. Okay, it's fairly easy to do, and you should be able to get your head around this fairly easily. So what we're asked to do is write down the null and alternate hypothesis for the following scenarios. So first thing, we've got a tennis player who has a fairly decent win percentage there. She decides to buy a new racket and wants to know whether her percentage is increased. Then we've got a school with a GC Maths pass rate of 65%. They have a teacher absent, and the school would like to know if this pass rate is decreased because of that. And the last one, we've got a school canteen. The proportion of students buying at least one piece of fruit, is 0.18. They have a bit of a healthy eating campaign. The head teacher would like to know if this percentage has changed or not, this proportion. Okay, so up here then, with the tennis player, what we call the null hypothesis, we write that as a capital H with a subscript of 0, and then we put a colon next to it. Now this is the same for every single hypothesis test. We do this all the time. Okay. Now the null hypothesis is basically nothing's happened. The win percentage is still the same, or there isn't enough evidence to suggest that it's changed. So in that case here, because we're talking about a probability here, P is going to be to 0.58. So that's the null hypothesis there. The alternate, oops, 1 second. The alternate hypothesis, we write it as H1. And then we just go back into the question here to find out. We want to know whether win percentage is increased. So the probability is going to be greater than 0.58. And that's it done. For every single hypothesis question, you'll have to do this. It's worth a couple of marks in the exam. It's easy enough to do, and it's just from reading the question. So this one underneath here, the null hypothesis, H0, probably can see what it's going to be. P, the probability of the pass rate, of somebody passing is still 0.65. The alternate hypothesis, H1, the probability has decreased. So it's at less than 0.65. Okay. Now, this bottom one here, you must watch out for. Okay, it's very, very subtle. So you need to be looking certainly in exam questions for anything which says different or changed. Notice these ones, it's quite obvious. We've got increase and decrease. Well, this one says changed, or it could have said, we want to know whether the proportion is different. So in this case, we just need to be careful. So my null hypothesis is still the same in terms of the proportion hasn't changed. So the probability of me finding somebody who has bought one or more pieces of fruit is still going to be 0.18. And the alternate hypothesis in this case still H1. And this time, because we're looking for a change, we're looking for that the probability isn't equal to 0.18. Okay, really important that we do get these distinctions. Now, I'm going to add a little bit more to this. It won't make any sense now, but it will later on. We would call this here a one-tailed test. Or I certainly call this one-tailed. Okay, this one is also one-tailed. I'm just trying to dive in with little bits and pieces now that students forget. So if you've got an inequality sign, in terms of greater and larger, it's one-tailed, but if you've got a not equal sign, it's what we call two-tailed. And you'll see that later on in the videos, but it's worth spotting that early and writing that down. So that's this bit done. So all I'm going to ask you guys to do is complete question 1 of exercise 22B, sorry. Pause the video, have a go at it, get it marked, and then come back to the video. Okay, so what we're going to look at now is a full-blown hypothesis test. So how you do it, and work from there. I would recommend to pause each question, jot it down, and then work from there. Okay, so here we go. So we've got Martin, who grows cucumbers from seed. In the past, he's found that 70% of his seeds germinate, and then he's going to try a new brand of seed, and then we're going to try and see if he should basically swap, see if the proportion of germinations increased. Okay. And I'm just looking at the question there, more likely, so it's going to be an increase. Right, first thing we're going to do is define our variable. So in this case here, we're going to say x is going to be equal to the number of seeds which germinate. It's almost like you need to set all the rules out before you start sort of doing the maths. Now you can see here, this is worth 7 marks here. This is a real exam question. I've got the mark scheme sat next to me so I can see exactly every single point I can make. So first thing we're going to do is begin to jot down the null and alternate hypothesis. Okay, so H0. Now we're looking for an increase. Now we know historically that the seeds germinate 70% of the time. So the H0 in this case is that the probability is still the same. There's still a 70% chance of the seeds germinating. Now the producer says these ones are more likely to germinate. So H1, the probability is going to be greater than 0.7. Okay, so far, just looking at the math scheme, I've gained 1 mark there. And I haven't even done any maths, which isn't too bad. Next thing I'm going to do is begin to write down the model. Now, hopefully you recognize this is a binomial model. This question hasn't asked us to write down any conditions, so I'm not going to get too worried about that. So x tilde b, and remember it's NP. So in this case here, it's 20. We had 20 trials. I'll say 18 succeeded, but we're not going to worry about that right now. So it's going to be NP, so it's 20 and 0.7. Okay, easy enough to do. Now, what we're going to try and work out is what was the probability that 18 or more of the seeds germinated using this model. So let's calculate the probability that x was greater than or equal to 18. Okay, and we have to use 18. If we calculate the probability of 18, it wouldn't make any sense. We'd need 18, 19, and 20. You'd have to calculate all the probabilities. Now, I'm using the Casio calculator that I've used in my other videos. Dead easy to do. I don't need to do any more 1 minus stuff. So if I just pull it up now. So here we go. So I'll go across to stats, distribution, binomial. This is a BCD because it's cumulative. It's variable. My lower is 18. My upper is 20. I've got 20 trials and 0.7. and that gives me a result of 0.035. So 0.035 approximately, which is equal to 3.5%. So there's only a 3.5% chance of us getting 18 or more germinations, which obviously there's a very small chance of that happening under this model here. Okay. Now, all we have to do now is compare this with the significance level. So the significance level is at 5%. Okay, so the smaller the chance, the smaller the significance level, the less chance there is of happening. So there's a really small chance of us 18 or more seeds germinating. So as 3.5% is less than, this percent sign off there, is less than 5%. Well, what can we say? Well, in this case here, we're actually going to reject H0. Okay, so what we're going to say is that actually, yeah, if 18 out of 20 have germinated, then the claim by the producer, well, we've got enough evidence to say, yeah, the producer's right, because there was such a small chance of it happening. Okay, now, so far on this question, I think I'm sat on 6 marks. Okay, which hasn't been too bad so far. Everything has been nice and easy. Now, what you must always do, some students I've worked with in the past have gone, right, I've gone to reject H0, that's it, I'm done. You must put this final sentence in, and you must include the word sufficient evidence. So I've typed them out because I just copy and paste them across. So this is a sentence you're looking for at the end for the final mark. There is sufficient evidence. Remember, we're talking about sufficient evidence here because we can only use the data we're given. Okay, and there you go. That's for 7 marks. That easy enough to do. Most students, if you are struggling at this point, it is all about the significance level here. Now that might be down to the fact I haven't shown you a binomial model yet, but that will be coming in the next video and look at critical regions. Okay, so you just get the probability, compare it with the significance level. If it's smaller than it, you reject the null hypothesis. Okay, I've got 4 of these questions to do. Obviously, you don't need to go through all 4, but it's good practice. Okay, so here's the next one. So this time we've got Suzanne, who is a member of Sports Club. She wins half of matches, and then I suppose it should say she's a tennis player. It doesn't really matter. She buys a new tennis racket. She wins 7 out of 10. And this time at the 10% level, we're going to try and see if the new racket has made a difference. Okay, so as before, we're going to write down everything we need. So first step here is to say x is equal to number of matches won. Okay, and the null hypothesis, well, in this case here, that's the probability of her winning hasn't changed. Sorry, it's still the same. So it's 0.5. We get that from half the matches. And H1, well, this time it says different. So that's the probability is not equal to 0.5. Okay, I'm just going to check this against the mark scheme. I'm sat on 2 marks. Okay, it's not too bad. So next thing we're going to do is write my model. It's under a binomial, NP. So N would be 10, because that's the number of games that was played. And the probability was 0.5. So we'd expect to win 5 games, wouldn't we? 50% chance. So we're going to ask really is 7 far enough away from those 5 games for us to go, hang on a minute, yeah, new racket made a difference. Okay, so what we're going to calculate under this model is the probability of her winning 7 or more matches. I'm going to take it straight from the calculator again. Okay, so just going to exit that. Back up here. The lower value is 7. Upper value is 10. 10 games. 0.5. and we get a result of 0.17. You don't need to write down all the figures, you just need to be able to compare against the significance level. 0.17. Okay, which is 17%. Now, as mentioned earlier, and I should mention this before, but we mentioned it earlier, this is what we call a two-tailed test. Now, if it is a two-tailed test, we're going to have basically sort of an upper and lower value. We're going to have extreme values. So if for instance, Suzanne had only won one game, we go, yeah, tennis rackets made a difference. If she won 9 games, yeah, it probably would have made a difference. So this is two-tailed. Now, if it's two-tailed, you must split the significance level into 2. So you're going to have 5% and 5%. So this will make more sense when you look at the next video, which is on critical regions. So if you've got a two-tailed test, you're comparing the 17% against the 5%. You split the significance level into 2, and this will make a lot more sense when you come into normal as well, because you can actually see it. So all we need to say now then is 17% is now greater than the 5%. So what we're saying is there was a fairly high chance of her winning, comparatively, of her winning 7 matches. Now, because the 17% is greater than the 5%, it's not less than this time, it's greater than, we're going to accept H0. And if I just show you 1 second what it would look like with 8 matches. So what happened if there were 8 matches? In that case, it was again, there was still a 5.5% chance of it happening. So even there, even with 8 matches, we still wouldn't have rejected H0. With 9 matches, though, I think we'd have got into it. So with 9 matches, look, there's only a 1% chance of it happening. So if it said 9 matches, yeah, reject H0. Okay. And with this particular question, we always need to finish off with a sentence. And there you go. There is not sufficient evidence this time because we're accepting H0 to suggest that it's made a difference. Okay, or you could have said there is sufficient evidence to just suggest that Suzanne's racket has not made a difference. Okay, so 7 marks that, fairly easy to do, nice to get on with. Just watch out for this two-tailed business there. I would personally, for me, I didn't do in this video, I should have. As soon as you've got a not equals bit, draw an arrow, put two-tailed, and just split significance level into 2. Okay. Okay, I've got another one here. This one's a lot quite wordy, but it's along the same sort of lines. It's just showing you all the different styles. I'm not sure why this one's worth less marks. I wonder if it's an old style question. Yeah, it's an old style mark scheme. Okay, so let's start with labeling or writing down what X is. So X is going to be the number of what we're looking at. People who prefer cooked. Fresh. Okay, so a number of people, apologise for my handwriting there, who prefer cooked fresh garden peas. That's what we're going to be measuring against here. Get our null and alternate hypothesis in. So let's have a look. Where is my claim? Sorry, right at the top. So it's normally at the bottom, but this one's at the top. So it's greater than 0.5. So H0, its probability is still 0.5. And H1 is the probability is greater than 0.5. Okay, so we can have this as a binomial model. N is going to be the number of trials, so we tried 50 people. 0.5, and it isn't part of this this course. I will mention this quite a bit in the next video. But if you multiply these two numbers together, NP, it gives you the mean of a binomial. So we'd expect to find 25 people who liked the cooked fresh garden peas rather than the frozen garden peas. Okay, so next thing we're going to do is we're going to have a look at what was the probability of me getting 29 or more people. And you might be thinking, well, that's not that far away from the mean, but let's have a look and see what happens. So the lower value is 29, upper is 50, 50 trials, and 0.5. And that comes out as 16%. Now 16% is fairly high percentage. It's obviously not massive, but when we talk about significance level, it is a lot more than that. So 16% is greater than 10%. So what we're going to do in this case here, we're going to have to accept H0. Okay, the probability is not small enough to go, yeah, there's a difference here. Okay, and to finish it off with a sentence, there we go. Okay, it is a bit wordy, but it's not worth chucking that mark away in the exam because you can't bother to write a sentence. It's the same thing over and over. These are fairly nice to do. The actual maths here, and I'll say this in pretty much all of the stats really on the course, is fairly nice to get on with. The maths is lovely. It's just lots to remember. Okay. Final example of hypothesis testing. Okay. Again, I've gone for lots of different styles, just so you can see what's going on. There are more spaces in the ones that you'll see in your exams. I've just condensed them a little bit. Okay. So first of all, let's define the variable. So x in this case is going to be number of Christmas holidays without illness since January 2007. So number of, now I'm going to write Xmas here because my handwriting is really bad with this tablet. Without since Jan 07. That'll do. That's me taking as many shortcuts as I dare take. Okay. So in this case here, let's write down what H0 is and H1. So H0 and H1. Okay, so let's have a look. So 65% would be the figure we're looking at because historically that's what it was. So probability is 0.65. And let's have a look. So it is looking for a decreased, increase, or change, or different, or one of those words. So it's decreased. So the probability is less than 0.65. Okay. Set up the binomial model. X is approximated by the binomial distribution. Number of trials is n. So the next 7 years he was measuring. Remember, the trials have to be whole numbers, and it's 0.65. So you can multiply these two numbers, and it should give approximate amount of days you should have had off. Okay, so let's have a look then. So he only fell ill during 2 Christmas holidays. So the probability x is less than or equal to 2. Let's grab a calculator. So my lower value in this case is going to be 0. My upper value is going to be 2, 7, and 0.65. That gives me a probability of 0.556. 0.0556. So that's going to be 5.56%. So it's right next to the 5% significance level. Okay, but we have to go on what we're given. So 5.56 is greater than 5%. So we're going to, in this case, going to have to accept H0. If it had been 1 day, so the probability would have been smaller. So just think about it in terms of when you worked out this number here, this gives you the probability of it happening. So the slimmer the chance, the more change that would have happened, because there's less chance of it happening. Again, I'm losing a mark in the exam, so I just need to finish it off with that sentence there. Okay, and that's hypothesis testing done on the binomial. Okay, the only parts I suspect students will struggle with is this final bit here, but you can write that out in terms of setting probabilities less than significance level, but that will come through with practice through the exercise. So what I'd like to do now is exercise 22b, but questions 2 to 12. Thank you very much for watching.